So the first objective of this experiment is, the first one is to determine the modulus of rigidity, maximum shear stress and strain, and Torsion ratio of the tested specimen. So the second one is to study the linearly elastic behavior of the tested specimen under torsion. And the third one is to obtain the relationship between the torsional load and angle of twist in a full range of strain until failure. So we go to the discussion. So the first question is, compare the result of this test between the experiment and reference value of modulus rigidity, pressure ratio, shear stress and strain. Comment on any difference of possible values error. So based on the modulus of rigidity, the value is smaller, which is error 1.5% than the original. It is because the steel is very low and ductility. For the pressure ratio, is the value of the experiment is lower than the reference value, which is 0.29. For the shear stress, we can see that the shear stress is a little bit different than the reference value. Also same for the shear strain, which is the experiment value is very low because it's brittle and of the specimen which is sealed. So number 2 is describe the behavior of these materials at its response to increasing the applied torque. So based on the behavior of the material, we can describe that when the torque of the material is high or increased, the shear stress and the shear strain will affect it too, because when it is twist, the torque will affect the shear stress and shear strain. Moreover, the conclusion of the material and torque is directly proportional. So number 3 is the Hooke's law is valid for the shear stress and strain. So the answer is it's not valid all on this because the Hooke's law is directly proportional with the shear stress and strain respectively. This law is valid only for the proportional limit of the material in the experiment occur. So question number 4 is describe the appearance of the fracture structure of the fracture surface of the tested specimen and discuss the mode of the failure. So ductile failure is the fracture of the material with large material deformation before fracture occur. Ductile fracture basically is the soft metal, rubber and more. So ductile failure is suitable for steel specimen. Brittle failure is a material without plastic. Plastic deformation is a very small plastic deformation before fracture. So the brass is a very suitable to be categorized as a brittle failure under torsion. So question number 5 is what should be to resist more torque, a solid bar or a hollow bar for the same material and the cross-sectional area. So the hollow bar is able to resist more torque because hollow bar is higher than the solid shaft and its value is more closer than the maximum shear stress. Moreover, the hollow bar has a very high of strength. Solid shaft is not suitable because it's very low and the value is not close enough to the maximum shear stress. So the conclusion of this experiment is based on the experiment above. We can conclude that the objective of the experiment, which is to determine the modulus rigidity, maximum shear stress, maximum shear strain, and Poisson ratio of the test experiment is achieved. So by calculating all these objectives, I can plot and make the graph to find the modulus of rigidity. Moreover, to study the linearly elastic behavior of the tested specimen under torsion and to obtain the relationship between the torsional load and the angle of twist, and hence obtain the shear modulus is achieved. After we find all the objectives above and also for the graph, we can conclude that the relationship between the torsional and angle of twist is directly proportional. After that, we can determine the elastic behavior of each specimen that be lesser to above that tested to prove the objective in the experiment. So from the experiment, I can also calculate how to calculate the solid shaft and angle of twist of the specimen and can see the fracture failure of the specimen in the experiment.
Assalamualaikum warahmatullahi wabarakatuh everyone. My name is Amirul Hazimin Roslin. Due to the low ductility of steel, the rigidity of modulus is lower compared to the reference value. The Poisson's ratio for the experiment is lower compared to the reference. This is because poor ductility of steels which affect the percentage error. The maximum shear stress has a big difference because of the low ductility material used. The maximum shearing stress of steel is low. Because of this, the fracture produced is brittle. The second question. The behavior of this material in this experiment will be the same as tensile test, where the torque is increased at the elastic limit, making the shear stress equal to the shear strain, thus leading the shear strain and shear stress to the final stress and then fracture. Brittle materials will be more complicated to ductile material. Third, yes, because as long as the stress is proportional to the strain, the rule of Hooke's law will be valid. Only until it reaches the elastic limit, then the rule of Hooke will no longer be valid. The fourth, based on the appearance of the fracture which is twisted with an angle and the mode of the fracture is ductile for steel and for brass is brittle. This is because the appearance for ductile fracture is relatively smooth and have spherical dimples of micro voids that initiate the crack formation. while brittle is shaped with an angles with fracture of the faceted texture due to changing orientation of the grain cleavage planes. And finally, hollow bar can withstand more torque compared to solid bar, even though they have the same material and the same cross-sectional area. This is because the polar moment of hollow, also known as relative zone, is bigger compared to solid shaft. The polar moment is used to endure the torsion load. Higher polar moment means higher torsion capacity. Therefore, hollow shaft can endure more torque compared to solid shaft. In conclusion, all of the objectives have achieved, which are to figure the modulus of rigidity, maximum shearing stress, Poisson's ratio, maximum shearing strain for the tested specimen, and to examine the linear elastic behavior of the tested specimen under torsion, and to attain the relationship between torsional load and angle of twist, and hence gain the shear modulus. There might be slight error in the data recorded because of a few factors, which is the apparatus fault and human fault. Steel will produce ductile fracture, while brass will produce brittle fracture. Higher value of torsional rigidity, modulus of rigidity, shear stress yield fracture at higher angle of twisting means that the material will be ductile, while vice versa for brittle. That's all for me. Thank you.
In this discussion for the torsion test, we have 5 discussion for this lab test. So for the first discussion is compare the result of the test between the experiment and reference standard value of modulus of rigidity, Poisson ratio, shear stress and shear strain, and comment on any differences and possible source of error. So I will show my answer in the screen. For the second discussion is describe the behavior of this material as it respond to increase apply torque. So once again, I will show my answer in the screen. For the third discussion is the Hooke's law for shearing stress and shearing strain is valid in this experiment? Explain the answer. So I will explain my answer in the screen too. The second last discussion is describe the appearance of the fracture surface of the tested specimen and discuss the mode of failure for ductile failure or brittle failure under the torsion. So I will show my answer in this screen too. Last discussion for this test is which should be able resist more torque, a solid bar or hollow bar of the same material and cross section area. Explain the answer. So for the last, I will show my answer in this screen. In conclusion, ductile material have higher torsional rigidity, modulus rigidity and shear stress yield and fracture at a higher angle of testing value, while brittle material have lower torsional rigidity, modulus rigidity and shear stress yield and fracture at a lower angle of twisting value. From this experiment, we can obtain the behavior of the material, such as in this torsion test we can determine that brass is ductile because of the specimen shape at a fracture point. Other than that, we have tested for steel too, and for the result is brittle where it breaks although the force is small and it fracture very easily. So for overall, we successfully studied the linearly elastic behavior of the tested specimen under torsion and achieved to obtain the relationship between torsional load and angle of twist and hence obtain the shear modulus.